graphing a quadratic. Kind of depends on what form it's in. And this one here, number 13, is in standard form. So we want to, first of all, this will open down because of the negative. So we know it's going to open down. Since it's in standard form, to find the vertex x, we take negative b coefficient over 2a. So that's going to come out to be, the negative of negative 8 is positive 8. 2 times negative 2 is negative 4. So my vertex x coordinate is negative 2. To find its corresponding vertex y, I have to plug this in. So I get negative 2. Negative 2 is my x, squared is 4. Negative 8 times negative 2 is plus 16 for my middle, and then minus 9 for the coefficient or constant. So we have negative 8, negative 16, or negative 9, and that's 17. So here I get negative 1. So my vertex is going to be negative 2, negative 1. Now at this point, I like to go ahead and plot this. Negative 2, negative 1. And it's going to open down, so I'm going to put a line of symmetry here. Now negative 9 here is also my y-intercept when it's in this form. So negative 9 is here, which means I do have its symmetric point as well. Now the last thing I'm going to do is try to find a y-coordinate that goes with x of negative 1. So I'm going to go ahead here. My x is negative 1. I've got to do direct substitution. So negative 2 times negative 1 squared is 1. Negative 8 times negative 1 is positive 8. And then minus 9. So this becomes minus 11 plus 8 is going to give me a negative 3. So I have negative 1, I go down to negative 3 for here. Again, a symmetric point. And again, we try to smoothly hit those points in a parabolic fashion. Over here, number 14 is in vertex form. So my vertex is going to be negative 4, negative 1, coming from here and here. My y-intercept is going to be, when I plug in a 0 here, I plug in a 0 for x, I get 4. 4 squared is 16. 16 minus 1 is 15. I should make mention that since in front is positive, we're going to have an up-facing or up-opening parabola here. So negative 4, negative 1, going up. Now here, y of 15, that's really not going to be graphable, so I'm not going to use that. So I'm going to plot some points now like I did previously. Except now I've got to do 2 x's. So I'm going to pick an x of negative 3 and an x of negative 2, because those will be relatively small numbers to deal with here. So I'm going to get negative 3 in for x. That gives me 1 squared. Minus 1 is 0. So that means I'm going to have negative 3 is 0, which also means I'll have its symmetric mate. When I plug in 2 there, negative 2, I'm going to get 2 squared minus 1. That's 4, and that gives me 3. So at negative 2, I'll be up 3. And again, I will have its symmetric mate kind of across from each other in these two cases. And now I am going to smooth my parabola in as best I can, and we'll get that. Part of working with quadratics is completing the square, and that's a process that can be kind of handy in order to help us solve quadratics. To complete the square here, I'm going to take, since this is a 1, I'm just going to take my middle term, divide by 2, and then square it. So I get negative 14 divided divided by 2 comes out to be, divided by 2 squared, gives me 196. So that's my completing the square. Now to rewrite this as a perfect square, I'm going to write it as m minus 14 squared. So really two answers here. I'm completing the square root constant, 196, and my binomial squared, m minus 14. Similarly here, again with the 1 here, this process is pretty straightforward. 19 divided by 2 squared. That's 9.5 squared, which comes out to be, I have a calculator here. Yeah, it's 9.5 squared. 90.25. So 90.25 will complete the square. One answer. And then my binomial squared will now be y plus 9.5 squared. Simplifying complex numbers. Simplifying complex numbers follows many of the common rules that we've used in algebra. I've got a real part here. I've got a subtract situation, which I'll distribute. I've got a real part here, so negative 4 plus negative 10 is negative 14. That's my real portion. Here I've got my imaginary part plus my other imaginary part, so when I add those together, I get negative 3i. This is all I can do. The real part cannot be subtracted or added to the imaginary part. This one, real part, 22, imaginary part, adds up to be 23, and that will be 23i. Again, when we give these answers, they need to be in A plus BI form. Multiplying complex numbers. In this case, I have to do a little rewrite here. And then apply FOIL. First times first is 9. My outside's negative 6i. My inside's negative 6i. And last times last, plus 4i squared. Now I squared is negative 1, so that I change and I just make an adjustment to my last term. Now I've got a real part, another real part for 13, and when I add my imaginary parts I get negative 12i. Foiling here. First times first, negative 8. Outside's negative 1i. Inside's negative 16i. Last times last is negative 2i squared. Let's adjust that last term since I squared equals negative 1. That causes sign changing. Real part and real part. Negative 6. Imaginary parts. Negative 17i. These last two bring up a different prospect here. We have to multiply by the complex conjugate there and there. Just a form of 1 over there on the right. So now we have to FOIL the top. So 6, negative 60i, negative 7i, and plus 70i squared. In the bottom, 1, negative 10i, my inside's positive 10i, and last times last is negative 100i squared. Now we have some adjusting to do here because of the I squareds. These cancel, which is the whole idea of multiplying by that conjugate. And the bottom I get 101. And the top, my real parts are 6 and negative 70 for a negative 64. And when I add my imaginary parts, I get negative 67i. Final answer, not too nice looking of an answer, but our answer nonetheless. Over here, my complex conjugate here is going to be 3 minus I. What we do there, we have to do here. I've got to distribute in the top and FOIL in the bottom. Distributing the top, I get 12i minus 20i squared. In the bottom, I get 9. My middle terms will cancel, and I get negative 25i squared. Let's do the adjustment. I squared is negative 1, so we end up there. I squared is also negative 1 there. So I get 20 as my real part, plus 12i, just to put it in right order. 34 in the bottom. I can factor 2 out of the top and a 2 out of the bottom, and they will cancel. So that would leave me, after getting rid of those 2 factors, with the answer looking like this.